Hello, in this problem now we will see the binomial distribution. Now this is an IB exam question, classical question. Let's see it. Mr. Burger teaches a mathematics class with 15 students. In this class there are 6 female students and 9 male students. Each day, Mr. Burke randomly chooses one student to answer a homework question. Randomly, very important. In the first month, Mr. Burke will teach his class 20 times. So basically, he will teach 20 days. Now, the first question. Find the probability that on any given day, Mr. Burke chooses a female student to answer the question. Now this is a relatively very simple question because I just need to find one random day, so I don't care about which day is it that she will choose a female student. How many students I have totally? 15. What's the probability to choose female? How many females there are? 6. So the probability is 6 over 15. Which is, if I'll simplify it, 2 over 5 or 0.4. Question B. Find the probability he will choose a female student 8 times. Now here, the problem doesn't say anything, but I should understand that it is a problem that is connected with binomial distribution. Why it is binomial? Because the only here the only choice I have is to basically to choose a female student or a not female student, which is in this case is male. But so I have always 2 probabilities. So basically I have a probability of success, which is choosing a female, and a probability of not success, 1 minus p, which is choosing a male. So now this problem, immediately you should understand that it is a binomial distribution problem. And it's relatively easy. I just now will tell you how to write correct the answer. Now, find the probability that he will choose a female student 8 times. So basically, I should say that my variable, which is, let's say, x, is following a binomial distribution. And don't forget, parenthesis here, the binomial distribution is always the amount of trials, n, comma, the probability of success. What I mean success is what I consider success. In this case, choosing a female. So basically, the variable x follows binomial distribution with number of trials, which is 20, because it's 20 times that he teaches, comma, what's the probability of success? I found it on my first question is 0.4. Now, this is very easy to calculate. I will just, you can use the formula for sure, but since it's an AI course and it's always with calculator, I will use my calculator. Let me bring it here. So my binomial distribution, I will go here. So I will have second distribution. I will go to binomial. Now because I want to calculate the probability of getting 8 only, so basically here is going to be, how many trials I have? 20. What's the probability of success? 0.4. How many times I want to have success? 8. So now I need to calculate how much is that. So the probability is 0.1797, which is here I should write, so the probability of getting 8 is 0.1798, which is basically 0. Round to 3 significant figures. 170, is it 7? 17, sorry, it's the same basically, we don't mind. 7, so it is 1 8. That's for question B. Now let me see C. Find the probability he will choose a male student at most 9 times. Now in this case they ask me if I will break it down. Basically now I can make it again a binomial distribution, where now my probability of success of getting male, the probability of getting male is, how many males I have? 9 out of 15. Now again my probability, the variable x will follow a binomial, because either I will get a male or not. It's the same as before. How many trials I have? I have again 20, but the probability of success getting male is 9 over 15. You can make it also decimal, but it is okay for now. So now be careful. The problem says find the probability that he will choose a male at most 9 times, and this at most means, in terms of probability, the probability x to be less or equal than 9. So 9 is included at most. If it would say less than 9 times, here this one would be 8, because it means I don't want 9, I want less than 9. But at most it means up to 9 and 9. So now here I also have the I must use here my calculator. Let me bring it back here. So now I will go to my calculator again, second distribution. I will go binomial, but not binomial now, not a PDF, which is I want to calculate a specific probability, but cumulative probability, because basically I want to calculate here in my problem, I want to calculate up to 9, which means 0, the probability of choosing 0 male, 1 male, 2 males, 3 males, and so on. So now I will go here, and then how many trials I have? 20. What's the value of success? 9 divided by 15. And value up to how many? 9. And my answer will be 0.127, 0.13. So the probability is 0.13, and that's a classical binomial distribution problem. Always, if you will see that you have a problem which gives me 2 choices, a probability of 2 things happening only, flipping a coin, choosing to go there or not going there, choosing to eat that or not eating that, it's the same, it's a binomial classical problem.